Hi all, this is Vasavi from At Home Tuition. In this video we are going to see theorem of area of similar triangles is applied on the problems. So first let us see what the theorem says. The theorem says the ratio of area of two similar triangle is equal to the square of the ratio of its corresponding sides. Okay. So let us see how we are going to apply this theorem on these problems. In figure, the line segment XY is parallel to the side AC of triangle ABC. Okay. So they say XY is parallel to AC. Okay. And it divides the triangle into two parts of equal area. So that means the area of this small triangle is half that of the area of the big triangle. Okay. Now you need to find the ratio of the side AX to AB. So let us just start with what is given. XY is parallel to AC. So what does that imply? Angle A is equal to angle BXY, right? So these two angles, I am talking about these two angles. These two angles should be equal since these two lines are parallel and this line AB is a transversal, okay? So they are corresponding angles. So I can say that BXY will be equal to this A. Similarly, this side, your BYX will be equal to angle C here, right? So let me write that. Angle C is equal to angle BYX because they are corresponding angles. See, when you try to say something which is not given in the problem, you have to support it with a proper reason, okay? So you can say it is corresponding angles out here. So since you have two angles of the small triangle and the big triangle equal, okay, to the corresponding angles, okay, then I can say triangle BXY is similar to triangle BAY. See, care should be taken, AC, okay? Care should be taken when you arrange this order, okay? It has to match with the corresponding angles over here. So, and for this, this is by AA similarity criteria, okay? They've asked you to write the ratio of AX and BX, right? So we need this and this. For this, what I do is, let me write, I'm going to use the area theorem here of similar triangles theorem. So I say that area of triangle, let me take the bigger one first. So this would be BAC, right? BAC over area of triangle, the smaller one I write down, of triangle BXY, okay, is equal to, I just take BX square. You can take any sides, right? So I just take BA square because we need AB, right? So I take BA square over BX square because that is what we need now. So I just take that side alone, okay, by area of similar triangle theorem. I just take this as equation 1. Now I just proceed. But what is given? Given that area of triangle BAC, okay, BAC over area of the smaller triangle BXY. So they say the area of the bigger triangle is twice that of the area of the smaller triangle, right? So it is 2 over 1. It is in this ratio, 2 is to 1 ratio here, okay? So 2 over 1. I take this as equation 2. So now from 1 and 2, what do we get from 1 and 2? This is area of triangle ABC is equal to this, okay? This is equal to this as well as this is equal to this. So I can just say these two are equal, right? So let me write BA square over BX square is equal to 2 over 1, right? What does that imply? That implies squaring both sides, you get BA, because we don't need the square of the sides. So I just find the square root on both sides. So I get BA over BX is equal to, when you find the square root, it is square root of 2 divided by root 1, which is again 1. Okay? Square root of 1 is 1. So I just write it as it is. Let me flip this. BX over BA is equal to 1 over root 2. Take away this from 1, okay? So you get BX over BA here, and here also you do the same. So that's 1 minus 1 over root 2. So here you get BA minus BX over, this implies BA over BX divided by BA is equal to, this side it is root 2 minus 1 over root 2. Okay. So this is nothing but, what is BA minus BX? Just look at the picture. BA minus BX is equal to XA, right? Or AX. You can write it as AX. So you get AX over AB. I've just written it as given in the question, is equal to root 2 take away 1 by root 2. Normally we don't stop with this, because when you have the rational number underneath, you just change it by multiplying it and dividing it by root 2. So therefore I get AX over AB equals, when you multiply this with root 2, it becomes 2, right? So that's 2 minus root 2 times 1 is root 2 divided by this root 2 times root 2 is 2, right? So this is your answer. They had asked you what is your AX over AB, and your AX over AB is equal to 2 minus root 2 by 2. Okay? Simple. You just use the area of the triangle, similar triangle formula to get this. Now let's move on to the next question. Here it is given, prove that the area of an equilateral triangle described on one side of the square is equal to half the area of the equilateral triangle described on one of its diagonals. Okay. So one equilateral triangle is on its side, and the other equilateral triangle is on its diagonal, and you need to show that it is half. Okay. The area of the square on its side is half that of area of the triangle on its diagonal. Okay. Now I have just drawn a square, okay, and I just drew an equilateral triangle which is equal to this base. Okay, I just drew an equilateral triangle on this side, and then I drew a diagonal, and there also I drew an equilateral triangle with this diagonal as its one side. So to make it much more easier, what I do is, let the side be A. Okay, if the side of the square is A, so let me write what I assume. Let side of the square be A. Okay, A units. So you know all these sides are A, right? All the four sides of the square is same, so they are all A. And this triangle on top is on the side, right? So the side of this equilateral triangle is also A. Did you get that? Okay, so I filled in all the, so therefore side of equilateral triangle on its side is also equal to A. Got it? Let us find out the diagonal, because we don't know the diagonal, right? Now diagonal of the square is equal to It is actually root 2, but I'll show you how I am getting that root 2. Okay. Diagonal will be, I'm just using the Pythagorean formula which we know. Your c square is equal to a square plus b square, right? So this will be square root of a square plus a square, which is nothing but square root of 2a square, and that implies root 2a. Okay. Yeah, because a square you can find the square root, it is a. So the diagonal you have got is root 2a. If this side is, the diagonal is root 2a, the side of this equilateral triangle is going to be root 2a, right? And this is root 2a. Got it? So therefore, side of the equilateral triangle on the diagonal is equal to root 2a. Okay, we got all informations needed. Now they've asked you to find the ratio area of, you need to show that area of equilateral triangle on its side. So let me write this: area of triangle ABE over area of triangle, the bigger one on its diagonal. Okay, down, I'm writing it down. That is CBF will be equal to the corresponding side square, right? Here you should know that this triangle and this triangle is similar because both are equilateral triangles. So the angles are 60 degree each, right? So I don't need to show that they are similar triangles because as it is, they've said it is equilateral triangle. Both are equilateral triangles. So all the angles are same, right? Here this is 60 degree. Even though it is bigger, the angle is going to be 60 degree. So by angle criteria postulate, I can say that these two triangles are similar. So I can write that the corresponding sides. So here I would write one side will be a, right? And here it is a square divided by root 2a the whole square. Did you get that? On top I have written its side is a, so that is a square, and here it is root 2a. That implies, that is equal to a square over, when you square the root 2 it becomes 2, and when you square the a square it is a square. So just cut the a square and a square, you get it is half. Okay. So the ratio is 1:2. Therefore, the ratio is 1:2. Hence, triangle ABE is half of triangle CBF. Okay? That's it. You have proved. Okay? I hope this video is useful to you. Thank you. See you in my next video. Bye.